For years, interacting with artificial intelligence meant asking a question and waiting for a response. Now, we are handing those systems the mouse and keyboard. The industry is shifting towards autonomous digital workers that log in and execute complex, multi-step tasks without needing a human in the loop. This transition accelerated with the unannounced release of OpenAI's GPT-5.5 model. Known internally by the codename Spud, this model wasn't designed to be a chatty assistant. It was built for long-horizon execution, software that can deduce why a system is failing and implement fixes across multiple microservices on its own. To achieve this, engineers implemented a 100 million token context window. Rather than feeding an AI small snippets of data, an enterprise can now ingest its entire codebase or decades of financial ledgers into the model's working memory at once. It allows the agent to hold the complete state of a corporation in its mind simultaneously. This capacity effectively makes the idea of an AI copilot obsolete. When a model possesses the technical intuition to navigate a network and the agency to rewrite its components, it no longer needs a human supervisor to tell it what to do next. But that autonomy comes with significant risks. In cyber range evaluations, these agents hit a 93% success rate in offensive operations, independently chaining vulnerabilities together to navigate restricted networks and exfiltrate data. We are seeing this same logic applied to our personal lives. Through a direct link with the Plaid financial network, ChatGPT can now access over 12,000 banking institutions. It views live investment portfolios and transaction histories, acting as an automated financial fiduciary for anyone with a subscription. This scale is being sustained by a recent diplomatic truce between the US and China. By trading soybeans for silicon, swapping massive agricultural exports for an uninterrupted supply of advanced semiconductors, the physical bottlenecks that once slowed down AI training have been removed. The response from the markets was a surge of optimism. The S&P 500 closed above 7,500, hardware stocks reached record highs, and venture firms secured total control over the emerging agentic ecosystem. However, while the stock market is celebrating, the engineers who built this infrastructure are reporting a different reality. Beneath the record valuations, they are describing a state of collective panic. The race for control has led to aggressive internal mandates. Microsoft recently forced its core engineering divisions to abandon popular third-party AI agents in favor of its proprietary tools, a move designed to centralize technical reliance ahead of the new fiscal year. OpenAI is following a similar path, utilizing a catch-and-kill acquisition strategy to absorb startups like Hero Finance and Roy. They aren't buying these companies for their products. They are buying them to eliminate competition and hoard the specialized talent required to build financial agents. These maneuvers sparked a viral critique from infrastructure pioneer Mitchell Hashimoto. He diagnosed the sector with what he calls AI psychosis, a state where organizations have become so fixated on automated speed that they can no longer have rational conversations about technical debt. Earnest, Hashimoto's warning is that this corporate mandate to deploy agents at any cost is blinding leadership to a breakdown in the basic principles of how software should be built. This friction is driven by a conflict between two engineering philosophies: mean time between failures and mean time to recovery. Mean time between failures is the traditional goal. It is the practice of building a hardened, resilient foundation that simply does not break in the first place. But because AI agents can identify bugs and deploy patches at light speed, the industry is shifting toward mean time to recovery. Developers are increasingly comfortable shipping fragile, poorly architected code because they believe the AI will fix the leaks before anyone notices. This creates a dangerous deception. On paper, the metrics look perfect. Bug resolution times are down and test coverage is up. But because the code is being refactored so rapidly by algorithms, the underlying structural integrity of the application decays without any human ever noticing. By trading architectural resilience for algorithmic speed, we are building a self-repairing catastrophe machine. The system continues to run, but its internal logic is becoming entirely incomprehensible to the people managing it. This reliance is fueling what engineers call the rewrite fallacy. Since AI labor is essentially free, companies are increasingly choosing to completely rewrite massive software systems every few months, rather than engaging in the difficult human task of maintaining and understanding them. The cost of this cycle is a permanent degradation of technical skill. As we offload logic problems to agents, the cognitive capacity for a human engineer to navigate a complex system or debug a critical failure under pressure is beginning to atrophy. Human programmers are being relegated. They are moving from being the master architects of digital logic to acting as janitors who blindly approve vast amounts of AI-generated code that they couldn't have written themselves. This cultural shift is being heavily funded by venture capital firms that often dismiss safety concerns as obstacles to market growth. They are betting that speed will always outpace the need for architectural stability. The result is an economy powered by an autonomous digital workforce that is increasingly difficult to audit. We have built a world where the software continues to execute, but the people who once understood its logic are being left behind as spectators.